So in this one, we are going to talk about private IP addresses. So the term private we use to talk about the IP addresses within the local area network. So let's say we have a network within home or within office. So usually we will use what we call private addresses. They are private, it's not visible to the outside. But if the device is connected to the internet, then there will be a public address, because within the whole internet, we need a mechanism to understand or identify the IP address of this machine. So that is we call public IP addresses. So usually, right, we can say the ranges. So the ranges are for class A, we can say for the class A, we remember, right, the starting, so the number. So it start with 10.0.0.0 to the last address goes as 10.255.255.255. This is the range. Now, usually we have about 16 million addresses, right? So if you use the slash notation, so this is usually put it as 10.0.0.0/8. So this is how we usually represent. We have the first 8 bits, right, for the network bits, and the remaining we have 24 bits, right, which means we will get about right, we will get about 16 million addresses. So we will have 16 million addresses. Too much, isn't it? Then class B starts with 172. I hope you remember the ranges by now. 31, 255, 255, 2, right? So that is the starting point. Sorry, I made a mistake here. It should be the starting point. So that means 1600. 16. We'll have 0, 0, 255 comes at the end. 0. And we will have 0. And this goes from 172.16.0.0 to 172.31.255.255. So in CRDR notation, we can say, right, 172.16.0.0 slash, we can say 12. Right? So we have this. Okay. So that means 2 to the power 12. Right? So no, not 12. So we have here, it's only 20 bits 12. The remaining we will have about 20 bits. So it's about 1 million address. We have 1 million addresses. And class C, and this is what normally we will use, 192, 168.0.0 to 192.168.255.255. And usually we see this And then we can say 0, slash the number of network bit is 16. Okay. So take down this. So usually you have 65,000 or something. So we will can have 64K. Actually, you will get 65,000 something. You will get it. So we discussed private addresses and public addresses. And this figure I told you, this will connect to the internet, and this is public address, and addresses within the local area network we can call private addresses. The next one we discuss is dynamic host control protocol, or DHCP server. That's the computer or server actually supposed to assign IP addresses automatically. Now, usually early days, somebody has to manually assign IP addresses, and with the DHCP, it will automatically, let's say we have 10 computers, IP addresses automatically assigned. Right. The next thing that we were are discussing is switching. So here switching, there are two types I will explain as packet switching and circuit switching. The term switching means data is actually forwarding from one place to another in a computer network, right? So let's look at packet switching first. So let's look at packet switching. So the idea of packet switching is when you want to send something, you first break this data into chunks or pieces, and then we call packets. And then each packet you are going to identify uniquely, and then you change the header. That means you need to send packet by packet, right? So that's what we see in packet switching. So basically you break data into packets. Right? So let me show you an animation where how this will happen. Right? So in packet switching, so let me share my screen. So you see here, can you see the screen? Right? Start from this host machine. The message is broken down into pieces, go through a lot of other devices and reach in the other machine. So this is called packet switching. So basic idea is the message you put into pieces, and pieces can go to in different places. When you want to send some information from Sri Lanka to Japan, for example, it may go through, lots of different other the networks, but at the end it will come to the same place. So this is called packet switching. Right. So what will basically happens there, we will have separate information put into packets, and the packets go through different networks and at the end go to the required place. Okay, so that's what we call packet switching. Right. Let's draw very small, diagram which shows this, right? Going from one place to another place, right? Going from one place to another place. So first of all, we'll write down packet switching, and then we'll next write down circuit switching. Right. So let me draw this one first, then we'll write down, right? So what you need to do is simply, you don't have to do with the a computer, just symbolize computer here, one place, another place, and basically use three colors to represent the packets here. And the first packet go through different nodes. These are other computers or other networks, what you see in the middle, right? And this one is goes in a different direction, like this. And this is again going from another direction, but at the end it will come to the required computer, right? So this is called packet switching. In packet switching, data breaks down into smaller blocks of data called packets. These blocks are then to the other host. Independent to each other. That means different packets may take different paths. And finally, meet at the destination. Right. I hope you understand. So packet switching, data breaks down in smaller blocks called packets. So data will be break into packets, small pieces. And these blocks are sent to the other host, right? That means the destination independent to each other. Independent means it can take different paths. For example, it likes you go from one city another city, but let's say you have several people can take different paths and then they can meet in the destination city, right? So it's similar to that one. So that's what we call packet switching. Then we will have circuit switching. So there are two ways you can send a message from one place to another place. First one we call packet switching. In packet switching, the message is broken into several packets, and packets can be independently go through the other networks and reach the destination, right? So that's what you see here. The three packets are represented in three colors. You see they are taking different paths, but at the end it will reach, right? So this is called packet switching. Now circuit switching is other way around, right? So it's dependent. Dependent meaning you have a dedicated connection, right? Early days we had telephone system like this, so that's why in this image I'm use to show you the representation. There will be a physical connection, one telephone to the other telephone. These are called circuits. We have switching offices. Early days in the telephones, they have manually connected to make the hard connector. So everything is connected with the physical wire, right? And then this is called exchange, right? And then this is the host. Let's say we need to send from here to here. So you have a dedicated path. So if you start from here, it will connect to here, and if this will connect to here, and likewise, you can get a physical connection between first phone into the second phone. So this is called circuit switching. So the circuit switching means we have a dedicated one, right? We have a dedicated switch. We have dedicated. Right. Now let's take down this. You can draw this. I will write down the text that you want to write down under this one. In circuit switching, so in circuit switching, instead of previous one, you have a dedicated link, a physical link you can see. In telephone system, there will be a connection wire from starting point to the end point. Right. So if you compare what circuit switching and packet switching, we will say packet switching versus circuit switching. Okay. No physical link. No physical. For packet switching, no physical link. In circuit switching, I told you already. For physical link. Physical link means no dedicated path. Yeah, right. Now, packet switching, I told you no physical link. Circuit switching, we have a dedicated link. Packets are independent in circuit, packet switching, I told you like they can go anywhere, but physical, right? Same path. Packets are independent. Take different. Right. පුතාලි ලියුම් කියන්නේ. Next, we are going to look at the role of transport protocols in internet, right? What are the things that we are going to learn here? So we need to understand a few things. We want to discuss, we have multiple applications, and then you have same IP, sometimes the port numbers, right? So it's not just delivering one message from one computer to another computer. So in this one, what we have seen earlier is delivering message or delivering a data from one point to other point. So it is not only the case, right? So IP address is not enough, right? Because we have different applications. So this is exactly what we are going to discuss, right? When you want to send some data from one place to another place, we have to look at this, right? So that's why we have ports and port numbers, right? We need to look at the data transportation. We have what we call port and port numbers, right? Now, for example, when you work in computer, you might work with multiple software, right? So when you have two computers, let's say, so in two computers, you might have multiple applications running. So you have to send data from one application to another application. Now, for example, now we are using Zoom application to communicate. So through the Zoom, I'm going to connect from my computer to your computer. I'm delivering my voice and my screen sharing to your machine. But at the same time, there are other software, right? Right now, I'm running PDF, I'm running Word, I'm running a few other software. right? Now, how computer understand, or when I want to send my data from this Zoom application to your Zoom application, it needs to identify different applications, isn't it? Now, අපි ගත්තොත් පොතේ අපේ computers දෙකේ තියෙනවා. දැන් අපි පාවිච්චි කරන Zoom software එකකින් ඔයාගේ Zoom software එකට තමයි data transfer වෙන්න ඕන. හැබැයි මගේ එකෙත් දැන් තියෙන application ගොඩක්, මම හිතනවා පුතාගේ එකෙත් දැන් තියෙනවා මේ වෙනකොට application ගොඩක්. ඒතර අපි තෝරගන්න ඕනේ අපේ application එක නම් ඒ අදාළ application එකට. එහෙනම් IP address එක විතරක්ම මදි. So knowing IP addresses is not enough. That's the first thing. Now for that, to handle with the software, we use what we call port numbers. I will explain, right? Port numbers. So we need use different port numbers, right? So you already know the the term port, because we discuss, especially when things are connected to the computer, we have physical ports like keyboards are connected to PS2 ports or USB ports and so on, right? Now, but these ports that we have mentioned in software, you cannot see, right? So these ports, the term ports are used to communicate from one application to another application. Now, for that, IP address is not enough, right? So when you work in a computer network, remember, you work with many processors, right? So for example, right now we are using Zoom. At the same time, I can read the news and I can send an email and so on. So for each, you have different processors, right? So to identify each process at a time, IP addresses are not enough. So that's the first thing we need to understand. Right. So how do you then identify the appropriate application? So this is exactly what we need to discuss, right? We have to have a set of numbers which we call ports for each applications, right? So this port information we have to connect to the IP address communication. Now, for example, now when we want to display some information, right? So IP address, and we have to use the port number. So you have to use both to communicate from one application to another application. So there are different port numbers. Now, for example, we know in web browsing, for example, our browser will communicate to another machine, get the data. So we will call HTTP, hypertext transfer protocol. So you have already know the protocol, and in the protocol we are using a specific port number. So in this particular case, TCP, we are using a port number 80, right? We are using port number 80. So there are different types as well, right? I think we'll first write down this one, because the idea there is, what we want to discuss is, for the same machine, for the network, we can have multiple software, right? Okay, so let's take down this one. So this is 6.8, right? Section 6.8, and we are going to discuss, explore the role of transport protocol in the internet, right? Now let's look at, we will put the subtopic as a question. Now the question is, right, why IP address is not sufficient to deliver a one machine deliver a message from one host to another host. We'll put in this way. One host means any device to device. Why it is not enough, right? So you can say that this. Now, first thing we have to understand, a computer is running many applications. We know a computer may run multiple, right? We'll say network application at the same time. Now, what's the problem? When you take a computer on multiple network application, there's a problem now. That means when you send one information to another, we need to know where you are going to deliver this, right? So this is very, very important, right? So when you have network applications, right? So we have multiple applications. Now, when you have multiple application, right? We have to way to recognize this, right? So when sending data from one machine, now let's say from one host to another host, we need to make sure that data is delivered to correct application, because when you have multiple applications, so how do you do this? So that's the question, right? For, let's say, each process, we know that each process means when you run a application, there will be a process. So each process of running application communicates to the network, the network through port numbers, right? We can say what is a port number. A port number used to combine with IP address A port number used to combine with IP address. To uniquely identify each process, in the given host. When you have port number, it's a number, let's say 80, right? Port 80 usually is used to communicate with the hypertext transfer protocol, we call it. Now let's write down some of the port numbers, right? Some of the port numbers. We'll write down some of the port numbers. There are many, but I'm not going to write down everything. Port numbers, examples, right? So right now, let's say protocol. Let me have a table. So I'm going to use protocol, network layer. I will explain this network layer later on. For the time being, we'll put that, and port number. So now we discuss IP address is not enough. When you want to communicate with the different applications, we need a protocol, right? First, now when you want to recognize emails, we have a protocol called SMTP, Small Mail Transport Protocol. Right? It works on TCP layer. I will discuss this TCP later on. And the port number is 25. Likewise, HTTP, Hypertext Transfer Protocol, especially we use to share web pages, and the port number is 80. Right? Then HTTPS, secure, Hypertext Transfer Protocol, secure. Right? Again, TCP, the port number is 443. Then file transfer protocol, especially when you want to send and receive a huge data, then we can use file transfer protocol. So again, this is TCP, right? We have 2021. Right? There are many others as well, like Telnet, IMAP, Secure Shell, DNS, and so on. But this is enough you to understand, right? Different ports and port numbers. Right, now once you do this, Now, before we move on to the idea of port numbers, now we discuss IP addresses are not enough because you are not just communicating from one machine to another machine, but you have to work with the different applications as well. Now, to talk to different applications, we can make use of port numbers. So that's what we said, right? Then I would like to discuss multiplexing idea. The term multiplexing we use to identify you combine and send multiple data, right? Multiplexing means you combine the data. So let's take down multiplexing. Right. So let's write down. Multiplexing means let's say multiplexing is a technique used to combine and send the multiple data over a single medium. Multiplexer or we call mux in short, mux combines multiple inputs to a single output. Demuxer, demultiplexer, so demultiplexer separate combine data, combine data into Right. So this is simply multiplexing is, right? I will give you a small graph for this one. So we can see, right? We have mux and demux, right? So this is the idea. So there are multiple lines you put into a one line, and when you receive demux, again you distribute in, let's say, n lines. So you can actually use multiple signals when you use multiplexing. Right. The last part for 6.8 is identify the different protocols we use. So we'll start with UDP and then we will talk about TCP. Right. Right. පොතේ ඇඳගෙන ඉවරනක් කියන්න.